Okay, what questions do you guys have today? Whoever.
For like number 2, I answer in decimal, but then what's the fraction? I'm still waiting.
On 2? On 5.6? Okay. So okay. Oops. Let me just actually work it out instead of trying to do it all in my head. So the integral 0 to 1 t square root 9 plus 16 t dt. We're going to take u equals 9 plus 16. Oh, that's why. Yeah, okay. So t is equal to u minus 9 over 16, and du equals 16 dt. Okay, so I've actually got the integral from 0 to 1 with the t's of u minus 9 over 16 times square root of u times dt is du over 16. So this is equal to the integral. I'm going to change these t values to u values. You put 0 in for t, you get u equals 9. You put 1 in for t, you get u equals 25. And then I've got 1 over 256, which is 16 squared. 16 times 16 in the denominator. And then, sorry, I've got u and u to the 1/2, so u to the 3/2 minus 9 u to the 1/2 du. So it'll be 1 over 256 times u to the 5/2 divided by 5/2 minus 9 u to the 3/2 divided by 3/2. Evaluated at 0 and 1, or sorry, not 0 and 1, at 9 and 25. So 1 over 256 times 2/5 times Well, I can do the 25 and the 9 in here. 5 to the 5th, that's pretty big. 30, 125. And minus 9 to the 5th, 3 to the 5th, 729. No, 243. 243. And then minus the 9-bit and the 25-bit here. Oh, I've got an extra 9 on that. And I got a 3 halves on that. Let me scratch that. Let's just do it the regular way. Okay, so that's 6125. Minus this one at 5 is, that cancels. That gives me a 3. That gives me a 2 up top, 2/3. Nope, sorry. 6. Six times 125, because the square root of 25 is 5. 5 cubed is 125. Okay, so that's evaluated at 9, or at 5, 25. Minus if we evaluate at 9 is minus 2/5. I've got 9 to the 5 halves. That's the 243. And then minus 6 times 9 to the 3 halves, which is 27. 30, 125, not 6, 125. Divide that by 5, you get 625. Multiply it by 2, you get 1250. Uh, 4 times that is 500, plus another 250 is 750. The 5s don't cancel there. That's not very nice. Minus 486 over 5 minus 162. So that's 14/5 away from 500 on top. So we'll take away 100, but then add the 14/5 back in. That's the easier way to do that one. Okay. So 562 plus 14/5 over 256. 25, 28, 10 plus 14 over 5 over 256. 28, 24 over 1280, which looks like it can reduce. 353 over 160. That's a lot of arithmetic. So hope I did it right. Okay, good. Okay, and then it's the next one that you said that was the issue. Yeah. You put 22 in there. Yeah. Honestly, let's just see what Wolfram Alpha says. So we want the integral of t square root of 9 plus 16t of t, comma 1 to 22. $91.77 and halves. I get that typed in wrong. Oh yeah, I did get that typed in wrong. I don't want that question. Okay. $592, $991, $160. That is a rather unwieldy fraction. But yeah, you good with that? Okay. What question did you have? Okay. 19? I thought. Did I click on 5.6 again? Okay. Feels like it's going to be one of those days. Yeah. This guy? Okay. So what part looks like the inside function? What part looks like the derivative? Okay. Okay. So of the major functions, what are the outside functions then? Sine inverse and the square root, right? Okay. The square root gives you what as its derivative? Gives you another square root, right? What's the sine inverse give you as a derivative? One over the square root. Okay, so I already have a 1 over a square root in here. So that looks like it's the derivative part of this. So I'm going to pick the sine inverse as my inside function. Or sorry, as my sort of my outside function, the substitution. So let's see. I want the integral sine inverse x over 10 squared square root 100 minus x squared. dx. The x over 10 and this 100 over the x, I'm going to rewrite things so it looks like x over 10 in the square root too. So if I factor out 100 from both of these and then move it outside, this is equal to the integral sine inverse x over 10 squared 10 square roots 1 minus x over 10 squared dx. See how we factor out 100 from both things in the under the square root? Okay. And then I'm going to take u equals that sine inverse function. So that du equals 1 over square root 1 minus x over 10 squared times 1 over 10 dx from the chain rule. And that's what we've got right there, isn't it? Okay. So this is equal to the integral of u squared to u, which is equal to u cubed over 3 plus a constant, which is equal to sine inverse of x over 10 cubed and a constant. Does it like the plus c's or not? It likes the plus c's. I didn't divide by 3. Does it not like arcsine cubed, maybe? Just didn't like the cube on the inside of the arcsine. Okay, that's fine. Okay. Other questions? Okay. Okay. So I'm going to draw a picture first. So this is the graph of f of x. What does the graph of f of x plus c look like? What's the plus c do to the shape of the graph? Translates to left, yes. And it translates it left by C. So if this is at A and this is at B, this whole thing gets shifted by C this way. This point is now down here at A minus C. This point's over here at B minus C. Okay. So if I wanted the area under the curve from A to B, it would look like that. Or after I do this translation, that A minus C is a little bit far, isn't it? Or it would look like that. The yellow area and the blue area are the same, right? So if I want the integral from A to B of f of x, I could take the integral from A minus C to B minus C of f of x plus C. Okay, let's see the algebra here. And we're going to take u equals x plus c, because that's what I want inside my function here. Or, sorry, no, that's not what I want. What do I want to replace x with here? I want to replace x with x plus c. Okay, so we're going to take x and replace it with x plus c. I'm going to call it x hat plus c, just so I can differentiate my two x's. Okay. It could be u plus c, but I'm taking x and I'm replacing with x plus c. So x hat equals x minus c. Dx hat equals dx. This is x equals a. So when x equals a, x hat equals a minus c, x hat equals b minus c at x equals a at x equals b. So this translates to the integral from x hat equals a minus c to b minus c f of x hat plus c dx hat. Does that make sense? Okay, so the u substitution, we're going to do, well, this is my u substitution. So we're going to put in the x minus c here. All right. It's either going to be x minus c or x plus c. They want the x plus c. Okay. Oh, they're going from the right-hand side to the left-hand side, maybe? Because you can show it that way too. Because here, if I put u equals x plus c, all that same stuff happens. Only I get like, I'm thinking of u as x in this case. This is my x hat, this is my x. And it's going a substitution from the right-hand side to the left-hand side. But the geometry is really what you should be worried about there. Because it's just a translation of the shape of the axes, basically. Other questions you guys have? Okay. Oh, we didn't do this one Friday. Okay, so we've got two boundary values, one for the derivative and one for the original function. We've got the acceleration. So to go from acceleration all the way back to the position, I have to take two antiderivatives. We're going to first find the first antiderivative, integral. Put the minus out there. 16 sine of 4t minus pi over 2 dt. Okay. So like I said before, this is linear, and by the time we're done with this section, we should be pretty good at linear substitutions. And what's the rule with linear substitutions? What's the easier thing to do than to actually write out the entire substitution? Okay. More like, okay, so with the chain rule, when your inside function's a linear function, we always multiplied by the slope. And that was the only thing you had to multiply by. So when you're doing substitution and you get a linear function, you have to divide by the slope instead. I think I said that at one point. So linear functions are common enough. We should just remember, okay, divide by the slope if I have the substitution. So I'm just going to look at the antiderivative of the sine function, put this thing inside, and then divide by 4. Okay. So what's the antiderivative of the sine function? The negative cosine. Yeah. And so I already have the minus sign out there. So this is equal to 16 times the positive cosine, because the negatives cancel, 4t minus pi over 2, and I have to divide by that 4. Okay. And I always have a plus c here. So I got 4 cosine 4t minus pi over 2 plus a constant, that's s prime of t. And we're told that s of 0 is equal to 500, so, or s prime of 0. And so that's 4 times the cosine of 4 times 0 plus pi over 2 plus a constant. Cosine of pi over 2 is 0. So c equals 500. So s prime of t, 4 cosine 4t minus pi over 2 plus 500. So far, so good. Okay. To get s of t, take another antiderivative, this time of this. Okay. Same idea again with the linear function being inside. I'm just going to divide by 4, so that 4 is going to just disappear basically this time. The antiderivative of the cosine is the sine. Antiderivative of 500 is 500t, and I've got my constant. Okay. So this is s of t. S of 0 is equal to 0, implies that this c is equal to 1 minus 1. Because this is sine of pi over 2 minus pi over 2. Sine of minus pi over 2 is -1. So C is 1. Let me actually write that out. Gonna have sine where we have questions on that. The 4. Okay. So the U substitution here, you're really doing a U substitution. Like this, and then you get du equals 4 dt. You're going to replace dt in here, and so this 4 comes down over here instead. And you get the dt equals du over 4, and that's where that divisibility by 4 comes in. Dividing by 4 comes in. Okay. So your U substitution is just that linear U substitution, but you should do it enough times that you recognize that you're going to divide by the slope, but you can just divide by the slope. Yeah. Yeah, you could use trig identities that this (16). That's it. You put in 0, you get -1. Is this is the negative cosine? Now I get a minus sign on this, right? Is that what you're saying? Use trig identities to get to there? Yeah. You can do that. Yeah. Because the pi over 2 didn't do anything. It was just carried through the entire deal. Because the substitution, it disappears when you take your derivative. All it is a translation. But yeah, you could do that easily. Is this the area between curves stuff? Okay, we haven't even talked about that. So I was going to talk about that today. So let's do that one and do a little lecture bit about area between curves. Okay, so first thing we did to find the area here was we took the integral from a to b, f of x dx, right? Okay, Why is that? Well, when we were doing Riemann sums, we had representative rectangles that we drew in. We found the area of each of the rectangles and we added them up. Okay, well, that's basically what this says. We're going to start at A, we're going to draw rectangles, we're going to end at B. When we draw our first rectangle at A, we draw our last rectangle at B. Dx is how wide they are. F of x is how tall they are. Okay. So basically what I want is I want a representative rectangle. I'm going to label the bottom of it. I'm going to label the top of it. And because the width, the narrow side, is in the x direction, it's going to be dx wide. Okay. And so here this is at an arbitrary x value between A and B, and the y value is 0. This is directly above this point. So this is going to be at an arbitrary x value, the same arbitrary x value, and f of x. And so the height of the rectangle is the change in the y's, which is f of x minus 0, which just goes here. That's the height of this rectangle. And the width, because they stack up in the x direction, the width is dx. Okay. I can do the same thing if I've got two curves. So I just want the area between f of x and g of x bounded by a and b. I'm going to do the same thing. I'm going to draw arbitrary rectangles in here. And for each of these rectangles, I'm going to start at A, I'm going to end at B. I have to figure out how wide they are and how tall they are. Because they stack up in the x direction, they're going to be dx wide. The bottom of this starts at some arbitrary x value with a y value of g of x. The top of it is that same x value because it's directly above it, right? F of x. And so the height of this rectangle is going to be the change in the y values, which is f of x minus g of x. Okay. So this area here is the integral from A to B, because that's where I start my rectangles and where I stop my rectangles. The height of the rectangles is f of x minus g of x, and they are dx wide. So this is the area of each of the rectangles from A to B, and the integral means add them all up. Okay, yeah. If the dx is approaching 0. So the idea is that this is the limit as delta x goes to 0. Sort of the limit of delta x going to 0 ends up being like a dx in some sense. But I'm going to start summing from I equals 0 to n. I've got my delta x, I've got my f of x minus g of x. Okay. And sorry, xi, g of xi. So this limiting thing with the sigma, there's a lot to it, but what happens is the heights basically stay the same because of continuity, right? As I'm picking a value in here, because this thing's continuous, it can't jump too high or too low. It's going to actually approach the end point where I'm evaluating as the width of this thing gets narrow. Okay. If you have a discontinuous function, you might have to worry a little bit, but we don't have discontinuous functions. And so on these rectangles, let's try and clean this picture up a little bit. Okay. So you're picking a spot to measure the height of this thing somewhere inside the rectangle from x to x plus delta x, right? And that height depends on the function value at those points in here. As this delta x gets smaller, these points start approaching this guy. And in the limit, because there's no weird jump discontinuities or anything, they actually do approach f of x and g of x, right? So the height of the rectangle approaches f of x minus g of x. Okay. And then the delta x, as it gets small, we still need the dx in there because it gives you that extra dimensionality. Because there is a limiting process here. It doesn't just go individually to 0. It does go individually to 0, but in the summation, it has to be balanced against, we're adding up a whole bunch of stuff. Okay. So the summation bit goes to infinity, the width bit goes to 0. Together they balance out and they go to from A to B bit. They go over this entire length. Does that maybe clear things up a little? Okay. So yeah, this is the area between the two curves. And then in our picture, we've got to make sure that we're finding the actual area, because if you take f minus g and you integrate the entire thing, over here, one of them's on top and one of them's on bottom, or we've got pink curve and blue curve, right? So they never actually cross, they just touch? Okay. If they cross, you have to do two different integrals. Since they don't actually cross, we can just go from -3 to 3 of the purple curve minus the pink curve, because the purple curve always stays on top. So purple curve always stays on top. I'm going to take the integral, because let me kind of draw this picture. What do you mean? Like, so you always want like the height of a rectangle. So we just have to figure out which one's on top and take away the bottom one from the top one. So I have a positive, like, does that make sense? Okay. So the top one is the purple one. We're good with that? And the purple one, I think, is the 4x squared. So we'll call that f of x. The bottom one, x to the 4th minus 5x squared. That's going to be g of x. So I'm going to take the integral from -3 to 3 of 4x squared minus x to the 4th minus 5x squared dx. And this simplifies a little bit first. 4x squared minus a minus 5x squared is a 9x squared minus x to the 4th dx is 3x cubed minus x to the 5th over 5, evaluated at -3 and 3. Because this is symmetric, these guys are odd, right? So when you put in the odds, you get the negative sign from the subtraction of this stuff after I put in the -3 becomes a +3. So this is really just 2 times 3 times 3 cubed minus 3 to the 5th over 5. 0 goes to 0. I'm just taking the right-hand side and multiplying it by 2, or looking at the algebra and working it out with that minus sign. But this is 281 minus 243 over 5 equals 324 over 5. Are we good with that? Okay. That was a very short lecture on area between curves. I was thinking about giving you guys tomorrow off. Is that good, or would you like to see more area between curves stuff tomorrow? You just still have next Monday. Number 13 has 3 functions. Oh, okay. So you're gonna go, you have to split it up into 2 intervals. You're gonna go purple over red as one of them. You have to break up the area. You do blue over red area, and then you do black over red area, and you add them together. Does that make sense? You remember those like area problems in grade school where you had like weird rectangular shapes with lobes and stuff, and you had to cut them into pieces and then add them up? That's what we're doing, only we're doing with calculus. Okay, so no class tomorrow. We'll answer questions on Monday when you guys get back. Also, the project's up. Make sure you check that out. Maybe get started. Yeah. So I don't need you to include like specific work. I want you to explain what you were doing. Yes. Yeah. Like if you want to go from this thing, well, I'd probably do those 3 lines. Here, early on, when I did all this arithmetic here, don't show me that. Does that make sense? Yeah. You can even skip some of the algebra stuff. Like there to there was, I mean, pretend like you're going to be reading this in 5 years. And if there's a step that you think, oh, maybe I won't remember how to do that in 5 years, put it in. If you're like, that's such an easy step, nobody would ever like miss it, then don't put it in. Does that make sense? Yeah. Just kind of think about the audience. I think I was trying to figure out if you guys can have a stuff due in dead week or not. And when I was talking to other people, since it's assigned so early, it can still be due during dead week. So if you want to think of it as due the 4th, just to get it done with, that's fine. But I will accept it like all the way up until the final.